Hello everyone, my name is Shihan Wang, and my supervisor is Mikola. This is the final presentation of data mining seminar, and my topic is the interpretable text mining. The presentation is divided into 5 parts. First, I'm going to introduce the motivation of the topic, and then is the method. After that is the approach I used, and the fourth one is the experiment. Finally is the conclusion. So the neural network has achieved considerable progress in NLP, and however, there are many black boxes in these deep learning modules, and the models are complex, and it's hardly for human understanding. Therefore, it is crucial not only achieve a high performance model, but also for human understanding the decision of the model. By understanding the model decision, it is more comfortable to accept the results. For instance, in a healthcare aspect, if the model predicts that a disease, and it's important to know why the model did that prediction, then have a high accuracy of the prediction. And there are many current of arts for explaining the neural network, and they have their own pros and cons. It is difficult to see which one is better than the other one. And Kindermans introduced a new state of art that they claim that they have a better interpretability than many other current state of art like LRP or deconvolve. Therefore, for this project, I would like to try their approach on the NLP task, because their experiment is on the image classifier. And I also would like to compare their approach with two popular interpretation techniques. So the four methods are integrated gradient, layer-wise propagation, pattern attribution, and pattern net. So the integrated gradient is an attribution method. It's starting from a zero embedding vector as the baseline, and the integrated gradient is the integral of all points on a straight line path from baseline to input. The attributions are add up to the differences between output, input, and the baseline. And using integrated gradient, it is able to avoid misleading importances score caused by the discontinuous gradients, but it can also lead to overhead to give misleading results. Layer-wise propagation using relevance score to indicate the weight of each word contribute to the overall prediction. So it's for each input variable in array input word and the target class, it will contribute the relevance score from the output up to the input layer, and the sum of relevance score of each layer are the same as the prediction score for the regarded class. So, for instance, the relevance score of neural A is the sum of relevance score from neural B up to neural A, where B is in the lower layer of A. So before we introduce the pattern net and the pattern attribution, we need first know what pattern is. So for data X, we can see it is a combination of signal S and the distractor S, a distractor D. So the output Y is the multiplication of WT and X in a linear module. The idea of pattern is actually the signal-based vector, which is AS. It tells the change of output that can be expected to be measured in the input. And Kinderman's in Kinderman's paper, they also introduced a high-quality measurement on signal S, which is the subtraction of 1 and the max correlation between output and the distractor. Therefore, pattern attribution, like its name, it takes attribution and improves upon the LRP framework. And the pattern nets produce also a layer-wise back projection of the estimate signal into input space. So my approach of the experiment is applied these four methods on a CM module as explanation techniques to get a relevant score of each word effect on the classification, and then compare them applying this relevant score as a sample weight on a support vector machines module. First, the CM module is you can see in the picture. Since Kinderman, they claim their approach works good on linear model. Therefore, I also choose a very simple CM module that only contains one convolutional 2D layer, and then use a max pooling layer and a dense layer to get the results. The dataset I used is a Stanford sentiment tree bank. It contains 11,853 movie reviews, includes 90,539 vocabularies. I used the split set label in the dataset to split training data and test data. So there are 6,920 reviews in training data and 1,821 reviews in testing data. So as you can see, this is the heat map of an example review. As we can see, integrated gradient, LRP, and the pattern attribution gives a proper relevant score for the positive words, where red means it gives positive score for the true class, and the blue means they give the negative score to the true class. So as we can see here, they see fun and good are positive words. However, the pattern net give opposite results. Therefore, I think maybe pattern net does not explain the module properly. So then we apply this relevant score as a sample weight on the SVM module. As we can see here, this one is the accuracy score of unweighted data, so which is the original training data and the testing data. The accuracy is 82%. So we can see this CM module is able to give a good prediction on this data set. And after applying sample weights, there is no big difference between these four methods. So we think this is because we got this relevant score from the same module, and then we apply the weight to the same CM module does not give any improvements. But for the SVM module, we can see after using sample weight, they improve the prediction significantly. But integrated gradient and the LRP gives better improvement. And we think this is because pattern net and pattern attribution they actually also using LRP framework. Therefore, there can be some bias when they are using the LRP framework. Therefore, we conclude that pattern attribution and the pattern net do not give better interpretability than integrated gradient and LRP for sentiment analyzed in a linear module. But there are more, or we would like to do the research on more details, since there are many reasons can vary the conclusion. First, they can it's possible that if we use another data set, it gives different results. And since the Kindman's paper, they worked on a simple model, so we can also apply them on a complex neural network. And it's also possible to use other approach to compare the methods. For example, word deletion approach to evaluate how to remove the most relevant word effect on the prediction accuracy. And it's also possible to optimize the signal estimator to improve patterns, since both pattern attribution and the pattern net are highly depend on pattern. So that could also be the reason why we got this conclusion. And that's all for my presentation. Thanks for your listening.